Okay, so this is really an intro to Kubernetes talk that I gave even before. So I just want to get a feeling on how experienced you guys are, so I don't bore you, put you to sleep. But let's just keep going. So what I want to talk about is building scalable microservices with Kubernetes and gRPC. And I'll focus more on Kubernetes for this audience. So have you heard of our Lord and Savior microservices? Please raise your hand if you follow the church. A few people, okay, good. So you're not alone. Microservices has been trending up in the past few years. Before it might have been called SOA, right? Like service-oriented architecture. This has a bunch of names that's been going on for a long time. And there's a reason for that, right? Even the Unix philosophy is write things that do one thing well and do it well together. That's really what microservices are. You're writing your applications that do one thing well, work well with your other applications together, and together that creates your full application. Why microservices? Tons of reasons. And then the real question is how, right? And this is where Kubernetes really comes into play and makes it a lot easier to write microservices architecture apps. So at Google, probably heard this many, many times, we run everything in containers. We launch over 2 billion containers per week, which is a lot of containers. And how do we manage all of those things? We use something called Borg. And Borg lets us orchestrate and schedule all these containers. And how do we communicate? We use something called Stubby, which is an RPC framework. And what we've done is taken those and made them open source. So Kubernetes is Borg, gRPC is Stubby. And instead of just making them open source and saying we're done, we wanted to work with the community, which is why we're here, and build it from scratch using experience that everyone has, right? All right, so Kubernetes, you guys all know what this is. I'm going to go through the basics for anyone who's on the YouTube stream, just for everyone is on the same page. So you have an app, let's call it app A. Now you've written this app, it works great on your laptop. You put it into a Docker container, it's working great. Now you want to ship it to production, right? How do you do that? So in Kubernetes land, what you would do is wrap it up in a pod. And a pod is just a collection of one or more containers that live and die together. So you can say like a web server and a logging sidecar, basic stuff. Then you wrap it up in a replication controller. Replication controllers let you scale up and down your application on the fly. The cool thing about replication controllers, if you don't know, is it's not run this many, it's keep these many running, which is really cool because if one dies, if a machine dies, it'll automatically reschedule that job onto another machine. Finally, the last part is a service. So all these pods are living and dying, having a great time. You need a way to find them. That is what services are for, right? So a service is your API endpoint. It is a static thing that you can always know it's there. You hit it, and it'll load balance your traffic across all your pods, 1 to whatever. You put all that together, and what do you get? You get a microservice, right? And that's pretty much it. For all you Kubernetes experts out there, these are basic building blocks. You put them together, and you can really make scalable applications. So if you have, let's say, 4 different microservices running in production, you can easily scale one up, scale one down, and update one with no downtime, right? And this is what really Kubernetes allows you to do, is build the Microsoft Office logo. I'm just kidding. Lets you really build scalable microservices in production as well. All right, so let's build. So now I'm just going to go through some basics of Kubernetes, and we'll go through some more advanced stuff if we have time in the end. So here's my machine learning application called Hello World. You can see it's just Hello World. Let's see. So what we're going to do is just build a Docker container. I'm not going to trust the Wi-Fi, so I've already pushed it up to GCR, which is my container registry. You can push it to Docker Hub or wherever you want. So I'm creating this, calling it frontend version 1, and I have stored it in the cloud somewhere. So at this point, we need to make a replication controller so we can actually run this. Highlighted the important things in red. The name is frontend. This is the label that all the pods that are running get. These labels, you can have multiple labels per pod, which is, we'll get into why you want to do that later. You can have 2 replicas. So on startup, we're going to run 2 copies of this thing. here's our image. We're going to run front-end version 1, and we're opening up port 3000, which is our Node.js port. All right, so we build that, run it, and now if we do a queues, we can see that we started running. No one can see that. Yeah. Yeah. There you go. Perfect. Yeah, so you can see that we have 2 pods running, right? And so if you want to resize that, you can do that pretty easily as well. Let's see if I have the resize command. Let's type in. Appreciate it, but that's okay. Okay, and then if you run that again, we have 4, right? So that's pretty easy. Now we have 4 of these front-end servers running on my cluster. Now we need a way to actually access those pods. How do we do that? We do that with the service, right? Our API endpoint kind of thing. So here we would have port 80 mapping to port 3000 using type load balancer, which on a cloud platform like Google Cloud or Amazon would open up an external load balancer. And then we're selecting, this is important, the name front end, right? So every single pod with this label will get traffic from this service. And we'll see why that's important later if I have time. All right, so let's start up that service. And if we do, right, so we started it up. Now we have a service called frontend running, and I like this format a lot. It shows you the IP, right? And this is clearly an internal virtual IP used by Kubernetes for the service. Now, how do we actually reach that service? The cool thing, eventually, is it will create a public IP for me. Just gotta wait. Wait. Oh, still not there. Nope. All right, so what it did is Google Cloud Platform created a network load balancer for me. So if I visit this website, there's Hello World. So yay, Hello World. All right, so that's pretty much the basics of Kubernetes. Just to get everyone up to speed on how this works. Yes.
Is that load balancer also managed by Kubernetes, or is your Google Cloud is managing that?
A little bit of both, right? So the external load balancer is managed by Google. The internal Kubernetes load balancer is managed by Kubernetes.
But mapping to that public IP is done by
Google Cloud, yes. And I think it's similar for most cloud services. Yeah.
Is the public IP automatic by default, or do you have to configure something?
Automatic by default.
Because I tried to spin up a service and I didn't see a public IP.
Right. So you have to specify. So if you're running on a cloud platform, like container, local machine, yeah, then you won't get that.
Right. So how does it?
So then, okay. So all right, let's pivot. So basically, at that point, what you want to do is use node ports instead, right? And then have your own load balancer, like say Nginx. Put that on a publicly facing node, and then have that load balance through your cluster, right? So you can do that pretty easily as well. But if you want a way to hit your external traffic, not cluster traffic, you had to open it up somehow to the external world.
Cindy,
yeah.
Could you repeat the question for people who are...
Oh, yeah, sure. So the question was, does Kubernetes give you that public IP address by default? And the answer is no, you have to set that up yourself, right? And I'm sure someone from the Kubernetes team could answer that in much more detail later on. All right, so let's just keep going right here. So this is about microservices, right? So the important thing is communication. I just came back from an API conference where we were talking a lot about APIs. That was pretty important for people, right? And so each of your microservices has to have an API to talk with other microservices. This is where Kubernetes actually makes it really easy to do that because of service discovery, right? So you can easily use DNS to find what other microservices are running, find their service, and then consume their APIs. So I'm using gRPC. For those of you who don't know what gRPC is, it is basically our RPC framework that we're using and open sourcing. So at Google, we have big O of 10 to the 10th RPCs per second. That is a really big number, like really, really, really big. I was kind of scared of writing that down. What does that mean? That means that it has to be really efficient, right? When your app starts scaling up, you're going to have more and more network calls going on the wire. And so you have to have very low overhead in order to achieve high scalability, right? So that's where gRPC really comes in. Some few things about it. It uses protocol buffers. How many of you have heard of protocol buffers here? All right. How many of you like protocol buffers? Oh, that's what I got. So this makes it, protocol buffers is what it uses as the default serialization format, right? So you basically define your messages in your services and things like that. So basically you have a .proto file, and what gRPC does is it takes this and then generates client and server libraries for you for all the supported languages, which is nice. The nice thing about protobuf is it's a binary format, so it's very compressed and very efficient. But the cool parts about gRPC is it uses HTTP2 as a transport layer protocol, which of course Kubernetes supports. Why would you want to use HTTP2? Because it is very fast, as you can tell by these two Go-Gophers loading very slowly. And you can test this out yourself at http2demo.io. But there's a few other reasons why I think it really applies to microservices. One is multiplexing. You can put all your connections through a single TCP connection, so you're not having the overhead of a new TCP handshake every single time you make a connection to the server, right? Which really saves on performance. You got bidirectional streaming. Bidirectional streaming means no more polling, right? You keep this pipe open, and when new events come down the line, you're automatically notified. So again, a lot of savings on your overhead and your performance. And finally, flow control. What is flow control? It means that if your service is getting overwhelmed with requests, you can automatically start throttling them down, right? So instead of having your network just flooded and then you can't even handle anything, you can say, hey, slow down a little bit and control that congestion and get back to sanity. Those are pretty cool features of HTTP2, and that's why we're using it. Multiple languages. This is also really important for microservices. You don't want to be stuck in writing your code in one language. You want to write in what language suits that problem the best, right? That's the whole point of breaking it up into different pieces. You can write one part in Go, one part in Java, one part in Node.js, or everything in Go. That also works. So what does that mean? What is multiple languages? So there's idiomatic generators, right? So you have the .proto file, and you can generate client and server code for a bunch of different languages. I don't have Objective-C on this screen, but also Objective-C. So Python, Java, Node.js, Ruby, PHP, all these good things. And you can generate those idiomatic libraries, right? And mobile first, I will just skip over that for now. It's basically, you can run on mobile, Android, iOS, and Windows Phone really easily. All right, so now let's upgrade our app to actually be microservices. And we'll talk about some more advanced stuff in the end. So here's my .proto file. You can see it's just really basic. I'm going to calculate the distance between 2 points on the Earth. Points, and distances, right? There's floats and a collection of points. Really simple stuff. And the interesting thing here is distance between takes an argument that's points and returns a distance. Right, so there's no code here. It's just an API definition of sorts. All right, so now we're going to add some backend code. So what we're going to do is load in that .proto file and create a geo service. What this is going to do is basically create a new server, right? So it's a new object, and we're going to define what that distance between function looks like. And because it's Node.js, we're going to use callbacks. In Go, you'd use Go routines, things like that. So it's idiomatic for each language. So you're going to call this getDistance function with the request that's coming in. What is getDistance? It is just the Haversine formula, which for those of you who don't know what the Haversine formula is, it's basically calculating the distance between 2 points in the sphere, right? Which is the Earth is a sphere-ish, so very simple stuff. All right, so that's pretty much our whole server. And then we're going to bind to 0000 551 and then start listening on port 551, right? Build it up, send it to the cloud. That's great. This is just Docker build, same thing, tagging it 1.0. Now my front end, we're no longer doing hello world. Instead, we're going to connect to our backend client and call our RPC service. So this is where Kubernetes really comes in. It makes it really easy. If you're using Docker to develop locally on your machine, you might link your two containers together, and you say something like, and you see the host file is like automatically patched with the name of that other container, right? In Kubernetes, it's very similar. You just call backend 551 as your server. This makes it really easy to do service discovery because you can just connect to the backend service without really hacking up your code too much. And we're going to get a request that's a latitude, longitude, origin, destination. And all we're going to do is go client.distanceBetween. So we're calling the remote function and then getting the response back and printing it out to the screen. And building that is easy as well. All right, so here we're going to create our backend replication controller. The only difference here is we're going to call it backend. We're going to use the backend image, obviously, and open up port 551. So let's do that real fast. With one hand. So now we have our backend and front end pods running. Now we need to do the service, right? So here the service, you might notice that I don't have that load balancer type specified. So this is going to create an internal Kubernetes service that's not exposed externally, right? So the load balancing is going to be done internally by kubeproxy itself. I think, yes, kubeproxy, right. So we're going to use port 551, and the selector name is backend. All right, so we're going to launch this. Nope, not that yet. Right? And so at this point, we have our backend code running. Now we need to run our front-end code, right? So with Kubernetes, it's actually really easy to update your code. And this is what that update portion that I talked about before was. It has a rolling update function, which means that it'll take your controller and start spinning up pods and spinning those pods down, right? And it'll keep replacing them and then replace the controller completely once it's done. So the nice thing about this is you can always rolling update backwards as well. So if you have an issue and you start rolling and you start seeing more and more issues come up, you can roll back to the original version with the same command, right? So let's try that out. I'm going to roll. And now, if I go back to my website and I keep hitting refresh, it'll eventually hit one of these. I should not have had 4 pods. I should have had 1. It would have been faster. We'll wait for this to finish. I hope it's not cached. Yeah, that's a good point. Still spinning up. So I'm still hitting the last remnants of whatever pod I had running version 1. Let's see, end of loop. All right, there we go. All right, so it finally hit the new service, and you can see that updated with 0 downtime, right? Which is nice. All right, so for all of you who've done all this before, it's very boring stuff, but let's talk about some more complicated things. I think I have like a few more minutes left, so let's talk about that. So one thing I wanted to touch was these replication controllers. I gave it a single label, right, backend. Now, when you're running microservices, you always want to, how do you update without downtime, right? That's a big issue. So one thing you can do is canary build, right? So you have a canary running. How do you scale that one up, and how do you divert traffic there, right? So what you can do is you can create a new replication controller and call it backend canary. And then when you have your backend service, this selector can select more than one tag, right? So you can select backend and backend canary. So you can now load balance with the single service to both of these microservices. And so a little portion of your traffic gets sent to the new microservice, while the majority of it can be sent to the production version, right? Or the stable version. And then once you're done and Canary's working, everything's fine, now you want to start rolling it up into the production, sorry, not the production, the stable version. All you have to do is rename those pods, relabel those pods into backend, and remove that canary tag, and then boom, right? Everything starts working automatically. And then your new canary is your next version. You can use rolling update, you can just rename the pods, rename the replication controller, what have you. There's a lot of ways to do it, but that's just one way that it makes it pretty easy to upgrade your stuff without really having to take anything down, right? Pretty cool stuff. Let's just open it up to questions. I know you guys probably have a lot. Yeah.
So kubeproxy can only load balance pods on the same node. Is that right or wrong?
Pods on the same node.
Yeah. Isn't there one instance of kubeproxy per?
Yeah. No. Tim's shaking his head. What's?
Proxy is a generic load. I don't want to say load balancer. It's a load sprayer.
Okay.
That will hit across any machine in the cluster.
Oh, okay. Okay.
Yeah.
All right. Okay.
So your question was, will kubeproxy?
Yeah, what I was trying to understand is if you have pods spread across multiple nodes, how will kubeproxy balance between them? But
It will. Yeah. Yep.
Can you control how much
Yeah. Yes. Yes, and the mechanism for rolling back is rolling forward. The mechanism for rolling back is just rolling forward. So what that means is, so right now the rolling update is done on the client side. So let's say like I just shut my computer off, right? So now it's paused halfway in between. What you would do is just roll update to version 1, right? And then it would just go back to version 1. Yeah.
Can you control how much traffic actually goes back to the backend? Like,
Can I control how much traffic goes back to the
You said
backend?
you had another label, load balance across all of the instances for all of
It would be, right now it would be random, right? So basically what I would have is I'd have one replication controller called backend and then one called backend canary, right? And then I'd say backend has 40 replicas and then canary has 4. Just by math, it would just
be like 10%.
10%.
Or not 10%,
Or-
whatever that is.
It is 10%, right?
44 machines, 4 of that.
Oh, 40, yeah.
Right?
Too much math for me.
Yeah, see? That's what that's
Almost 10%.
Question, when you do in the Node.js applications, you calling the service, the
Yes.
backend and port.
Yes.
So where do you define the backend? Is the Kubernetes generated?
Kubernetes, right. So that's being done through DNS. So basically it's saying backend, what is backend? And then the backend service is saying that is me, and then sending it to the appropriate pod.
So the question in your replica controller, you define the selector with the name backend. If I name backend 1,
Yes.
I have to
screen sharing. of doing that. So why do you need a replication controller?
You need a replication controller for. I'm sorry, I lost the question there. Too many inputs at once. Try one more time.
Let's say an example. Let's say we are running Cassandra on this.
Yes.
Cassandra is going to replicate on its own.
Cassandra will replicate the data, right? But if a Cassandra node dies, something has to bring up a new node, right? So Cassandra is a great example of sort of cloud native generation of applications where it doesn't assume that its data is going to be durable, right?
What's the benefit of the replication controller?
Replication controller starts the new instances. So if you start up your 5 Cassandra nodes, right, and the machine that one of them is running on, Cassandra itself is not going to pick a new machine in your cluster and go start up another Cassandra. If you start up another Cassandra and it finds the other Cassandra nodes, then it will start the replication process, right? But something has to be responsible for actually kicking that off. I'm turning it on. I'm running out of time. Let's talk about services real quickly. Services, again, Sandeep talked about it, is a group of pods that work together. It's sort of a load balanced set, although it doesn't have to be load balanced. That's really the most common case. I'm going to skip the demo because I don't have time for it. But if anybody wants to see it afterwards, I'll have it around and you can come by and take a look. I'm sorry. So the idea of a service is you get a stable IP address. We tried to figure out how to do service discovery. And inside Google, because we do this thing with port brokering, service discovery is kind of a nightmare because you never know what port your thing's going to be on. And DNS doesn't really handle ports that well. And so we decided we wanted our service discovery system to be DNS because everybody and their brother knows how to use DNS. And so we thought, well, what do we need to make DNS work? And the biggest problem we have with DNS is, well, if the IP addresses change to a first approximation, every DNS client in the world is broken. Right? They cache results. They don't respect TTLs. They don't revalidate their DNS lookups. So let's make sure that they have a stable IP address. How do we give them a stable IP address? So we implemented a virtual IP model. And virtual IP means that no matter what happens, wherever you are in your cluster, you have a stable IP address that is your service. So if I'm in my pod and I do NSLOOKUP foobar, if I have a service named foobar, foobar is there. We pre-populate all your DNS search paths so that your namespace, I didn't even talk about namespaces, your namespace is in your search path. So anything that's local to your namespace automatically gets looked up with a single word, right? How neat is that? It's sort of like Docker links, if you've ever used Docker links, where you say, I'm going to inject a host name into my linked thing, except a service can be any number of backends. I can have 1, 2, 10, 5, 100, it doesn't matter, right? And they're going to get round robined more or less. If the IPs change, they change. Unlike Docker historically, where once you're linked to that IP address, and that's it. Although I guess they fixed that recently. We also can run headless services. Some people say, I want the set concept, I want the set management, but I don't need a virtual IP address. What I really need is the set. I want all the IP addresses. So if you ask for it through our API, then you'll get a headless service, which doesn't give you a stable IP address. It gives you all of the A records for all of the pods that are backing your service. So then when you do an NSLOOKUP of foobar, you get 4, 5, 25 records that show you the IP addresses that you're currently back to. The assumption here is you have explicitly opted out of the virtual IP. You must know what you're doing.
So the virtual IP address for service is created when I create the service. Is that correct?
That's correct.
So by actively deleting the service, we create that service. Is there any way to guarantee that it gets the same IP address back?
You can ask for a specific IP address, and if that IP address is available, you can have it. If it's not available, you'll get a failure to construct at the API.
Is there a way to reserve those?
There's not a way to reserve those at the moment, although we're starting to work on a claims model, which would let you be able to do sort of claims like that. The claims model is more focusing on external IPs, public IPs, but I think it's going to extend to this model as well. Do I have time? Or am I done? I'm sort of done. Let me throw the last one out. Secrets. So this is something that we added for our 1.0 release. Secrets, oftentimes you want to run a pod, you need to give it a password. What's the password to the database, or what's the Docker key to get at your hub, or what credentials do you need to get somewhere, an SSH key, those sorts of things. So for God's sake, you don't want to build it into your container, right? I mean, everybody knows that's a terrible idea. 12-factor apps, anybody knows 12-factor apps? Yeah, good. 12-factor says your config comes from the environment, right? Decouple configuration and code. So to us, that means you should be injected at runtime, right? Just like we believe in software and dependency injection, we believe that if your pod is your class, then I'm dependency injecting your secrets, right? So what happens is you create a secret object in our API, and you feed it secret data. I've also got a demo for this if people want to come by and take a look. You feed it some secret data. It stores it in the API server. It's in your namespace. When you create your pod, you just reference that secret from a volume. We create a tempfs directory. We mount that secret. We create some files in the tempfs directory so it never touches disk. And then that tempfs directory is available to your application. So now you can put your SSH key in there, and when you go to run SSH from your application, boom, it just works. Pretty neat trick. This is something that I think other people are starting to catch on to, and I think it's a really great way to do injection. A lot of people have historically used environment variables. They assume 12-factor environment means environment variables. We take a different interpretation of that. I got about a quarter of the way through all my slides, which I knew would happen. Let me quick answer any questions before I turn over to whoever's next. Yeah.
So with regard to like the Cassandra concept, like, you know, are you suggesting that you would use a replication controller to?
So Cassandra is an interesting case in that Cassandra has a couple of wrinkles that Kubernetes doesn't handle properly in terms of identity. But we do have a Cassandra example in our code base, and it absolutely you can use replication control.
Now, what about having like you know, the persistent data or whatever? Like let's say you have Cassandra scheduled onto a certain machine.
Yes.
You have a volume. You're saying that if that goes away, does that include like the machine is rebooted?
So we have a timeout period for when a node goes away, on the assumption that sometimes a node goes away and comes back within 30 seconds. And the cost of actually spinning up a new Cassandra node and replicating all the data is probably more expensive than a 30-second degradation in service, right? And so it's sort of a finger in the air, like how much is too much to wait. If you wait forever, obviously you're going to have degraded service. If you wait 5 seconds, you're going to be bringing up things that you don't need to bring up.
You set that per service?
You can, not currently. Currently, it's a global timeout for the node, but we have an idea that we want to bring in called forgiveness, which basically says I'm willing to accept an outage of this many copies for this much time. And then the system would know, well, you've already got one degraded, and the second one is out. I'm going to fast bring up the other one because now it's too much, right? Quick to throw this up, a bunch of stuff that's new in our 1.1 release, which is coming out in a few weeks. We've already cut the release branch for it, so we're just working on stabilization. But we've got all sorts of wicked cool features like cluster auto-scaling. We'll just grow and shrink your cluster as you need it. Jobs, which run to completion. We have cron jobs. We have turning on privileged containers by default, so people can stop yelling at us for not doing that. Graceful termination, so your job will get a notification before it goes away. Downward API lets you pull stuff out of our API and inject it as a volume into your pods. Again, same idea as secrets. Simpler deployments. The rolling update is a really neat demo, but it's a little complicated, and sometimes you just want somebody to manage that for you, so we're going to do that. Interactive containers, you can actually like kubectl exec into your containers and run an SH and see what's going on in your container and maybe run GDB against it or figure out what's going on with your debug logs. New network plugins, we're moving to this CNI network plugin model, so you'll be able to tie into all sorts of new networking. We're upping the performance goals. We're growing our scalability from 100 nodes to 250 in 1.1. We're adding HA masters. We're adding new scheduling tweaks and making scheduling better. Cluster federation is coming soon. Easier cluster setup. We're working on making the whole thing easier to bring up. More types of volumes. Private Docker registry comes with it out of the box. And L7 load balancing has been introduced. Whew. We've been busy for the last 3 months. This is 3 months of work. So an average of 40 PRs a day. So we've been busy. This is the quick plans. We've got a whole bunch of people who we're working with, Red Hat and CoreOS and Deis and Mesos, are all and Mirantis, don't forget them, are all building distributions of Kubernetes and integrations with Kubernetes. So if you want to get started with Kubernetes, these are all people that you can, and Kismatic who's over there, and I don't have their logo up, I'm sorry. We should do that. But there's all these people you can talk to. Last reminder, Kubernetes is open source, it's open community. Come and talk to us if you have something that we don't do that you need us to do. We want to hear about it. Or if you have a great idea, we want to hear about it. If you think we're idiots, well, you keep that to yourself. That's it. If anybody has more questions, I'll be sitting over on the sides while you're doing these other talks, and then we'll have a lot of free time to talk afterwards. Yes? Oh. I'll publish these slides too on Speaker Deck.
Yeah, we also posted on the Meetup.
We'll post it for the Meetup link, and I always post my slides on Speaker Deck, so you can go see the evolution of this slide deck.
Thank you, Tim. Thanks a lot. As Kim said, he's just going to be here for a while, so we can just have all your questions covered.
We're here all night. There's a couple more talks to do, so come by and see us later, and we can show off the demo.
So we have two questions.
What's that? No, totally blew it.
What we're gonna do is we're gonna see how well you guys are paying attention. We're gonna ask some expert questions. So how we're gonna do this is the first person who raises their hand, I'm gonna pick that person and they're gonna answer some trivia questions and I'll hand them a t-shirt. So who can name 4 API objects that TikTok about? He raised his hand first, but then he put it down. That's all.
API server, Kubernetes controller, Kubernetes scheduler, Kubernetes kubelet, and Kubernetes proxies.
Those are not API objects. Those are
Oh, the
actual-
Kubernetes controller manager.
those aren't API objects. I'm talking about the things that you create with API.
Half credit.
One more.
All application controller service.
All right, yeah. I mean, you large using
Endpoint
next one. This is a container question. Can somebody name 4 namespaces? Willing namespaces. Yeah, that's correct. Okay. No, sorry. All right, this is a expert question. Does anybody know an experimental feature that is coming out in Kubernetes 1.1 that showed up on the last slide? What's next? What was that?
Clustering, enhanced cluster management.
I don't think that's all right, yes, that counts. And, next question. We have one small and one medium. Next question. What is the abstraction that we use to aggregate endpoints and route traffic to endpoints? You were the first to raise your hand.
I was gonna say kube proxy, but I'm not.
And then, yes, okay. And another container question. Name 3 container runtimes.
Docker, Rocket, system.
All right. I only have a small, I'm sorry. Thanks, guys. But we have a bunch of stickers. We're gonna make it into a t-shirt. I'll leave a bunch right here for when the presentation is over.
Awesome. Thanks, Mike. Representing. So now we have Patrick. Patrick is CEO of Patrick. She's here to show us about all the new lines that's there on Kubernetes and what more. So you talk.
Okay.
There's the right side.
Do you have an HTML?
So it's VG and then we have just 1 second, let me just share this with my view.
What is like
Are you?
All right, so I'm Patrick, one of the co-founders and CEO at Kismatic. We started with Kubernetes back when we were still at Mesosphere. We're all former Mesosphere people. And we had just finished building the DCOS based on Apache Mesos, and we had all the rich visualizations and things that we built in. And we realized that Kubernetes, Kubernetes didn't have any of the stuff built in. So we started to work on that. So when you go to your API server, you go /UI, you get the Kubernetes dashboard. And the bar that we came up with were meant to be super simple and still convey a lot of information. And what we're trying to do is look at what you would see, what would you want to have on like a 16-inch display corner, where you can look at the cluster and see where there's any problems. And we wanted to make sure that we had everything that you could do with the command line or anything that you wanted to read. We want to make sure that you had access to that. So you click on view, you can go. So some of those technologies change. I didn't make a screenshot, but being able to go through, look at events, in a web UI, imagine here you see this, this issue, you can send us directly to one that you can call right back into the spot, where you can find special access. This is all available over SSL, with your username and password that you get a cluster, so you still have security built around it. So pretty much anything you build in CLI, you can do in the web UI. And this is the first shot that you had doing this. And we had kind of a limited time frame when we went to build it out. All of it's available under the Kubernetes organization on GitHub. And we've been trying to think, like, what do we want to add next? So one of the big issues we had in the first version is we only supported a single namespace. We didn't have other namespaces. And we wanted to add, add that support. And we also wanted to make sure that we had the ability for other people to add, new features as well. So if you see up as well with the graph, that graph tab is an example of another component. The way history. Let me just pause this for a second. The way the it's actually running the UI of a container, and the service endpoint that it's pointing to is below this. And if you wanted to build your own tab, there's just a manifest file that you create. And since this is all coming to the API server and you have that proxy address, you can actually route to whatever you want to. You just call CPLN across any course issues and get around that because on the API server. If you want to do your own component in your company and use all the data services and things that are already built in the UI, it's super trivial to do that. You basically make a container with your custom code and then use that manifest file, and then it just automatically appears as a tab across the top. You have that. You don't have to customize any of the Chrome, and all of that just stays the same. So some of the features that we wanted to add, like right here, you can see I'm looking at it faster. I can see the running on that node when it was created. But one of the integrations that we want to work on was for containers. Actually, make that image clickable. I'd like to be able to click it, pull down a copy of that, make it fixed. Let's say I was using this from what screen?
Just one. We want to use
presentation. It's a screen.
Which one?
Is there, I didn't have a screen. Maybe because this is full screen. No. Is it now? Pardon? Okay, so go a little less than full screen. You see it now? How many technologists does it take to use Google Hangouts? 3?
So as long as you see the chance, it's going.
Okay. All right. So anyway, lightning talk, lightning fast. So some of the things that we wanted to add were really natural. One is to be able to put, the container image right here where you can click it, pull it down. I mentioned like Oops Docker on your machine, you just go pull that down, make a change, check that into your container image, updating your configuration and now you're running the newer version. And it's exciting to me to think about like, all the things that I could do without ever having SSH, into a host, without ever having to touch, anything on the cluster. I can just go to the web UI, make changes, change the configuration, and go from there. So start playing this again. So this, like I said, this was our first pass, at doing this and just trying to get these features in. And now that we have moved on, we want to add some new. Now we got the V1. Now we want to add some new features. So we've been prototyping out some other ideas because the Hangout not being able to go full screen. Let me see if So we were trying to think like what are the new things that we want to add. So here we have like cluster namespace settings. I can say here are my available clusters. Here's the available namespaces. I can create a new namespace, add a cluster, and it'll save those configurations. So now I can have multiple clusters whether dev, stage, testing, whatever, all available to me. And then they're like little bug fix things, like making sure the file systems that come back are in the right order. Because we have an issue now where depending on how the API returns the data, we might put them in a different order. So every time you reload, it's slightly different. And then if I was to dismiss this light box, you'd see, being able to see kind of world update of like how many services, how many pods, everything that's running. So with Tectonic from CoreOS, which is their release of their Kubernetes distribution, they're really giving us a run for our money with the open source because their UI looks amazing and looks great. And we want to make sure that the open source free UI looks as nice and is as compelling. So if you go to the KubeUI repo under Kubernetes, you can create issues. And I would love for anyone to put any kind of pie in the sky ideas, what you would love to see, and just kind of write out the scenarios. Like, I really wish it did X, Y, Z, whatever. And we'll try to address those issues and get them done. And also, all of the code is using Angular material and Angular. So it's super simple to actually add new features to. You don't have to be a hardcore JavaScript developer or front-end developer to actually add things. And one of the partnerships that we did early on with this project was with the OpenShift team at Red Hat, and making sure that we're not trying to reinvent the wheel with everything that we're doing. So if you look in the original organization on GitHub, we actually share a lot of components. So we've agreed that like all the services that we use are reading the API in the same way, parsing the API objects in the same way. So we don't have kind of issues with people doing things differently. So everything that works in all of the Red Hat projects should work here. So like their topology graph, you could just drop in and use that in your own component. And we really wanted to make sure that it was super simple for people to add components without having to learn a bunch of new things. So if you have questions about like getting started building your own component for the UI, feel free to add an issue on GitHub under the project and say like, I'm trying to do it. And one of the things that we're hoping to do right around the KubeCon time is to do during the hack day, have like a UI hack day and help people along. And at that point have kind of a hello world component. So at least people have some process guidance on how you create these. Because in most environments, you're going to have custom things that you want to have for your organization that aren't going to make sense necessarily for other organizations. And that's really what we thought of from the beginning. Is like, how do we make it really easy for you to make those custom dashboards? And one of our thoughts was like, individual components like the topology graph and Red Hat and things like that could just be drag and drop things that you enable to build your own visualization. And we also wanted to be able to, I don't have a demo of the Kubernetes working right now, unfortunately. I had some issues with a test cluster I was trying to set up last minute. And that happened. But we want to build the Kubernetes stuff right into the KubeUI so it's not separate endpoints, and we just have one way to link to both things. But yeah, that's really all I had. If anyone has any questions, feel free to ask them. Anyone? Not someone, give me something. You, sir, you gotta have something. No?
Well, yeah. So what is your plan in terms of enabling accessibility, right? I mean, things like this is a node view, being able to sort. What are other attributes besides, file system?
Yeah, so what we have now is like CPU, memory, file system, space, but like the obvious candidates for the bar gauge. And it was a nice way to kind of visually show all of that. We're adding the concept of like service counts and all of that. We wanted to be able to also show kind of anomaly detection. One of the things that we were focused on when we first did the graph tab, being able to show things like, okay, this event keeps happening, like this spread is master is going away and coming back, going away, coming back. Like there's obviously something wrong here. A way to kind of bubble those events up, like too many of this thing have been occurring in too short a period of time, and try to add some intelligence. So those are things that we're definitely thinking about, adding as well.
So are you targeting operators primarily, people to manage clusters, or people to performance management clusters?
So the idea is like not targeting a single group. It's make sure that we have a view that works for everyone. Like the kind of view I envision in my head of like you're in the corner of the ops room would be something like the bar gauges, but smaller without the legend. And so if you actually take the KubeUI and bring it up and resize the screen, once you get to a certain size, it actually gets rid of the legend and just has the bar gauges and then dynamically lay out. So if you're in a cluster with 100 nodes, it's obviously going to look different than a cluster with just 2 or 3 nodes. And we wanted to be able to have as much information available as possible. We also played around with the idea of trying to put the service and pod count overlay inside of it, but it just kind of got too cute at that point. So determined that like putting it across the top here made more sense. And forward-looking, one of the things that we really want to add in, and something that we added to GCOS, was a thing called starting line, where people that don't know how to make the configuration, for bringing up a service would just have a WYSIWYG, way to do that. So we envisioned something like the light box where, it's additive as you start filling out, shows you all of the, if you try to do a typo of the container name, it would say like, I don't see a container called that in the registry, like it's not going to let you progress to the next step. Or if you try to say, violate the resource boundary of a machine, it's not going to let you do that. Like you don't have any machines in your cluster that have 32 gigs of RAM available for this, so we're not going to let you make that config.
Thank you. Thanks a lot.
Oh, thanks. It's a bomb. Let's get on with it. Stop sharing. Sorry, I'm still. Why won't it stop?